Hey guys, Mrs. Traver here. Today we're going to talk about absolute value equations. Our learning target is you'll be able to solve equations that have absolute values in them, and you know you'll be successful when you can isolate the absolute value and then write two separate equations to solve for each of the answers. Let's jump in first with a review of what we've done previously, where I've got a problem where there's two binomials being multiplied. As a reminder, you can use FOIL or box method on this situation, and then the next one where you can either distribute or use a box method as well. Let's do the first one here. So if I did FOIL, I would have all my arrows with F, O, I, and L. You would get 12x squared for the F. O is 30x, 6x times 5. The inside term's negative 22x, and then the last term is negative 55. You can combine these two like terms, and you'd get 12x squared plus 8x minus 55. That's your final answer. You would have got the same thing with box as well. For this one, I prefer distribution. So I've got negative 2 times 15 is negative 30. X squared times x squared is x to the fourth. And then negative 2 times negative 3 is positive 6. And x squared times t is x squared t. That's a 6, not a b. Kind of looks like a 6. Or 10 kind of looks like a b. All right, moving forward. So I want to try one like this. It's a little bit of a challenge. You've got a binomial equals a binomial. So take a minute and try this one on your own. My suggestion is to do box or FOIL on each side separately. And then we'll pause right there and take a red light before we can move forward with green light and move forward. Try it now and see how it goes. Okay, so hopefully you did box or FOIL on each side. For the left side, you would have got x squared plus 7x plus 12. And on the right, you would have had x squared plus 3x plus 2. Check yours with mine and see how it went. Now, what's weird is we have an equation with x squareds in it on both sides. Let's get all the variables to the same side. I'm going to subtract x squared from both sides. And when I do that, notice they actually each cancel. So now I'm in a normal equation land. 7x plus 12 equals 3x plus 2. We're used to these equations. Let's get all the x's to the same side. I'm going to decide to move the 3x to the other side. On the left, I have 4x plus 12. And on the right, I have 2. Then I can get the 12 to either side, so all the numbers are on the right. So I've got 4x equals negative 10. And lastly, if I divide both sides by 4, I've got x equals negative 10 over 4, or simplified negative 5 over 2, or as a decimal, negative 2.5. That one wasn't too bad, other than the weird part with the squareds on both sides. Let's look at our real lesson for today now that we've reviewed a little bit on absolute values. So before I jump in too far, I want to remind you what absolute value means. Absolute value is a distance from 0. So we've actually seen these before, but not with equations. So like before, I would have given you like absolute value of 2. And we think of that as how far away from 0 is 2. And that's 2 away. Sometimes I'd give you a negative in here, which would be the situation, how far away is negative 5 from 0? And it's still 5 away. Now, though, we're throwing x's in, and a's and b's and other variables. So in this case, this absolute value of x equals 5 is really telling you that the distance x is away from 0 is 5. So in this case, if I think about it like on a number line, here's 0, x is 5 away. So it could be at 5, or it could actually be 5 away the other way, and x could be negative 5. So that's kind of how we solve these. What we do is if the absolute value is by itself, I could say, well, either the inside x was 133, or the inside x was negative 133. So we're going to get two answers, and we'll write it like this, x equals 133 or negative 133. And I literally write the word or out. Don't write it like this, because that feels like a point, and that's not how I want to think of it. So literally write the word or out with these. You'll get two answers for each of the absolute values. The next one is a distance from 0 for x is negative 2. Now, this one's kind of weird because it's saying the distance is negative. The distance from 0 is negative 2. Does a negative distance make sense is my question to you. Hopefully you said no. Distance can't be negative. Distance has to be greater than 0. Like, for example, if I drive to school 5 miles, When I go home, I don't say I drive -5 miles. That doesn't make sense. I'd still drive 5 back. So in this case, we've just recognized that the absolute value of something, anything, has to be greater than 0. So therefore, this problem should be no solution as an answer. Let's try some more. On this one, we have an absolute value of some stuff equals 10. So I know this stuff on the inside, x minus 7, was either 10, or the stuff on the inside, x minus 7, was -10. Now we have two equations we can solve for. These are nice one-steppers, so all we have to do is add 7 to solve. The one on the left will be 17, and the one on the right will be -3. My final answer I'll write in one line, 17 or -3. Let's try another. This one, the absolute value is by itself. So what's on the inside, 3x minus 5, either equals the positive 16 or 3x minus 5 equals the -16. This one on the left I can solve for. It's got 2 steps. We'll add 5 first, and then we'll divide by 3 to get 7 for the first one. The second one, we'll do the same 2 steps, adding 5. In this case, I'll get -11, and then dividing by 3, which this is just, I'm going to leave it as a -11 over 3. It's not going to simplify. So my final answer, I can say 7 or -11 thirds. Let's try another. Actually, let's try this one on your own. So take a minute, freeze your screen here, pause your video, I should say, and try this one out on your own. All right, I hope you gave it a shot. I've got my first equation, 7 minus 8x equals 1, and my second equation, 7 minus 8x equals -1. I can solve each of these by first subtracting 7, and then by dividing by -8. -6 over -8, those will both become positives, and I can reduce 6 over 8 to be 3/4 or 0.75. On my second equation, same 2 steps, subtract 7 first, and then divide by -8. And in this one, I get a nice answer of 1. So my final answer is x equals 3/4 or 1. Let's try another. Now this one that's coming up is going to look different. Can you tell the difference here? If you said that there's something outside of the absolute value, you're on the right track. So what's different about this one is that the absolute value is not by itself. Notice in our previous examples, absolute value by itself, absolute value by itself, absolute value by itself. This one, though, is not the case. Let's get the absolute value by itself so we can treat it like the rest. It is 8 times the absolute value, so I'm going to divide by it to go and get rid of it. So I have absolute value of -10n equals 10. Now I can do what I normally do. Either -10n equals the positive 10, or -10n equals a -10. On each of these, I'll divide to solve. On the first one, I'll get -1, and on the second one, I'll get +1. So n equals -1 or +1. So now you can kind of recognize our steps. For absolute value equations in general, you have 3 steps. Number 1 is to isolate the absolute value. What that means is if there's something outside of the absolute value, like an 8 here, maybe it had +2 or something, then you want to get rid of that first so the absolute value is by itself. Then set it up so you have the inside equals the positive, and you have the inside equals the negative. After that, you want to solve each, and you've got your answer. I should say you've got your answers. Let's try another one of these. This one again has something outside of the absolute value. I'm going to get rid of the 7 first by adding it to both sides. So I've got absolute value of m minus 1 equals 6. Now it's isolated. I can set up the inside, m minus 1 equals the positive, and the inside, m minus 1 equals the negative. Only step to solve here is to add 1 to both sides, so you'll get 7 and -5. So m equals 7 or -5. All right, I think it's time for you to try a couple. This first one is nice and straightforward.